today I do a medium problem, sum of subarray ranges. Since I went through 4 hard problems and all of them looked unsolvable under half an hour, and I don't have more time because I have exam tomorrow. So sum of subarray ranges. A range of a subarray is the difference between the largest and smallest element in the subarray. Return the sum of all subarray ranges. Okay. What this allows for? Okay, they have follow up with on and then n squared. I mean, okay. Sum of all subarray ranges. So first let's do n squared. So let's say we start at I, and then int max is I, min is j, not I also. Okay. Should work. Let's change the type to long because max cannot work on long, so yeah. Okay, now it's not gonna work. Let's do it like this. So that's n squared solution. Clearly that's slow. They want something linear. Okay, so let's see what could ranges. Let's say we let's say we have like a range that this is max and this is 5. So this is max in all these subarrays. Could you find a solution with this time complexity? Well, I would need to calculate. So let's say I am here and I want to calculate the answer for all these things. Well, what could change? Well, let's say I have calculated it for these subarrays, so this one and this one, and I know min max for them. And now let's say a 3 comes in, so I increase the range of each one, so I know the answer for the previous one. And now how does answer from that? Well, it increases everything that is larger, something. I don't have that. Okay, so let's say I start with 4, and then when I'm evaluating this, I care how many times. Well, here we have 4 ending in 4 here, so max 4 here, max 4 here, and then here it would be max 5, and then it would be max 5, and so on. And then if I do the same with minimum, then at each point I know what. That's not a lot, to be honest. I know prefix minimum and prefix maximum, and what can I deduce from that? I'm actually not sure. Okay, so in what arrays will it contribute that exact 4? Well, it will contribute in all subsequent arrays and then if you go from back on the prefix, what happens? Well, this tells me that well, what if I have suffix maximums? Let's say I have like I don't know, 2, 5, 10, minus 2, 1, 5, 4, 11, 1, 1. Now suffix maximums are 11, 11, and prefix are 2, 5, 10. Well, what does that tell me? So let's say I want all year. Well, what do I know? I know that 2 contributes there. No, you don't. Okay, so maximum out of this, we know in that prefix. Maximum out of this, we might not know. Like suddenly, okay, we see that Maybe let's calculate the difference. What can they be? A lot. Okay, maybe not. So how many times does that exact maximum contribute? Well, until we find maximum, a larger number. So until when is this a max? For how many ranges starting here? Well, not many. How many ranges here? Okay. So what I need to compute is next greater element. I can do binary search or stack, I think. With stack it's possible. So it contributes this many times. So this 5, how many times contributes? Well, twice, right? So for this and for this. So that's subarray starting here. And what about subarray starting here? Or here? Or whatever, right? So that's this. Now it doesn't contribute. But it also is in this and this and this. So I take well, it's these two starting options and these three ending options. So I do previous greater and previous larger, and then I add this times this times this, and then I do same for minimum. So I find next smaller element, so it's minimum so 4 is minimum for this, and this is smaller, and then it's minimum for this, so it subtracts. Okay, I guess I can do that, so it's just gonna be a pain. Vector int next greater element, next smaller element, and then we have previous greater element, and then previous smaller element. Okay, and now we go from, we have some sort of stack int, that's what, a decreasing stack and increasing stack. So now while not decreasing empty, and numSi is over nums decreasing top. Then we want to set next greater element of decreasing top is I, and decreasing pop. And now y, okay, we're going to decreasing push I, and now while increasing empty, and numSi is smaller than nums in nums. Okay, then we do next smaller element of increasing top is I, and we pop from there, and then we push increasing push I. next greater element should have n. Next smaller element should have this. Great. So next 0, 1, 0, 1, 2, 3, 3, 5, 5. Okay, and then the next smaller element 1, 2. This is 5, this is 5, this is 4. Okay, that works. Now we wanna do it. Compute next greater slash smaller element. Great. Compute previous so I have a decreasing sequence of, so these are decreasing, and now while for oral umzai is this, then previous smaller element, okay, and then this should be previous greater element, and then okay, so previous smaller element is here or greater. Oh, I'm marking the wrong things. So I'm going left to right. Previous smaller element, like that. Okay, so previous smaller is at index 1, previous smaller is this, and I don't have bigger, don't have bigger, don't have bigger. And this is previous smaller is at 0, this is at 0, and this doesn't have, and larger, 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 at 3, this doesn't have, this has at 1, this has at 0, this doesn't have, and previous smaller is at here, here, and then this doesn't have, doesn't have, doesn't have. Okay, so we got the computations correct, now we just have to use them. So as is this. So, okay, so we need the size 1 is, well, let's go at left, is I minus previous greater element of I, and right is next greater element minus I. It's fair, I guess. And then ans plus equals nums I. I should probably do left times right times nums I, which I hope converts, and then the left is I minus previous smaller, right is next smaller element, left, right, it's maximum in just this, but it's minimum in all these three, so let's see again. So it's -2 because it is minimum in all these, so you have to subtract it 1, 2, 3 times and add it once. This is what? 12? No way it contributed many times. Maybe it should be with equal signs. Maybe now it will work. One case worked, that's great. And this now didn't at all. Oh, I mean I'm off, so that sucks kind of. So 3 contributes to 1, 2, 3, 4, 5 ranges. So it's 2 plus 1, 2, 3, 4, 2, 3, 4, 5. This is fair. No. It's in 1, 2 ranges. It's gonna say too much. It's gonna say 7. It's in 1, 2, 3, 4, 5 ranges. I agree with that, and it's smallest in only 1. Okay. Then this is largest in 2 ranges. In 2 ranges. And smallest in these 2 ranges. Okay, then this is in 1 range, so it's in 3 and 3, so 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay. What time is it? Oh, it's 04 already. It's not looking good, man. to hurry up with this. Let's diagnose it on this one because that seems easier. So 1 should be smallest in what? 3 subarrays. Great, so -3, that checks out, and it's largest in 1 subarray, so checks out. Okay, now that 3 is largest in 1. These ties are not looking good, bro. Well, it's minimum only in 1 to the left and 2 to the right. So 2 options, right? So it's minimum in 2, and this also says minimum in 2, so 3. Okay, that doesn't quite sell it because now I'm double counting. Well, if I go for next greater than or equal to element, I think what should happen is this. This will decrease the answers, but I will increase. Let's check. So if PGI is this and PGI on then left plus plus PGI I do have so many hair. Nah, that's completely off. Almost. Little overcount. I don't know how to solve it, to be honest, because now I have conflicting subarrays. Because okay, 4 is in how many subarray? 1, 2, 3, 4. Maybe I'll do it only on one side. Now this is wrong. Oh my days, bro, hell no. Okay, 2 contributes to maximum in 2 subarrays here and 2 subarrays here. But suddenly we have a problem with this, because this contributes to max here, so that's 1, 2, times 2 is 4, and then this should only count as 1, but it doesn't. Maybe if I do this. Okay, still doesn't pass. And if I do this. Now the other one doesn't pass. Okay, I'm just trolling here. Well, the problem with this is that I'm counting some subarrays twice, so how to count them once? Next greater than or equal to element. I don't know, bro. I can't solve it. It's been half an hour. Let's look at the hint. Okay, that was only help probably for. I thought it's gonna help me, but because the problem is that this contributes to its maximum in this, right? So number of elements here times number of elements here, but problem is that I have this and then this and then this, and that's only 3, and that's too much. So I have to subtract somehow the subarrays that both of them have, and that's I don't know, I put too much compiler knowledge in my head. But I might solve. Let's see. How do you count all those subarrays just once? Because okay, what is the problem is that when I only look for the larger element, then I'm counting some subarrays multiple times. launcher, I don't know. 2 loops. That would be great to calculate, but I got this, I have this, but there is conflict. Okay, that's fair. That's too much edge casing for my liking, but okay. How you even, what's mid, stack, pop, and what's left? Why is, what the freak? Why? I mean, in the index, that doesn't matter. That are close or adjacent. But why though? So you only find smaller than or equal to element? That is weird. So to right, but to left you don't? Okay, I mean I was kind of missing that, but so I find this next. Okay, and here should be this, and now it might work, maybe. Ah, okay, interesting. Yeah, I couldn't figure out how to not double count. That's interesting. Okay, all and done. Let's go. Stacks. Monotonic stacks. I don't think I would figure that out. I have to remove this, so let's remove it from here. Great. Intuition. For each number we count its contribution as a max element of subarrays and subtract its contribution as minimum of subarrays. The answer is sum overall numbers. How to calculate brute force is obvious, just track maximum and minimum for each subarray starting at 0, at 1, blah blah blah. As for the ON approach, the number of subarrays a number is maximum in. Well, let's find the next larger element to the left and next greater than or equal to elements to the right. Let those positions be left and right respectively. Then the number of subarrays containing bullseye as maximum is and also is right minus I times I minus left. Then we can do a similar thing for the minimums. We can similarly calculate the number of subarrays bullseye is minimum in. We need to know next slash previous greater slash smaller slash we need to know closest next greater than greater slash smaller than or slash smaller position. We can do this with let's show how to find next greater element. We keep elements which need decreasing sequence of elements, needing needing looking for a greater element in a stack. When we process nums I, we assign nums I as next greater number to all positions on the stack that are smaller, and finally we push nums I onto the stack. Works because elements after nums I cannot be closest next greater element to the elements in the stack. Finally, to avoid double counting, e.g. in 133 do not count 133 do not count 3 as maximum in and twice we looked for closest next greater and closest previous greater than greater than or equal to element. When since we do we compute the previous slash next elements in ON, each ON, since each element is pushed on a stack O1 times and popped from it O1, and calculations are O1 per element. ON since we store next greater positions for each position. Okay, that's enough. That's not the greatest explanation, and I'm not really sure still about these things, but who cares at this point? I don't. Goodbye.